Hello, welcome back. So in this video I will continue with the wiring diagram for the PLC circuit shown in the previous part. As you can see here, I have generated this wiring book, let's say, using the Electrical Spark Design software package, and those are the pages available. Here we have the first page denoting the cover page, followed by the drawing list. And here we have in the third page, we have the wiring line diagram and the power supply. Then there is the PLC control circuit, specifically describing the inputs connections. And the next page describes the outputs connections. And afterwards, we have the actual power circuit. And afterwards, there is the operator interface wiring and the power cabinet. So let's start by having a look at the modified operator interface. Here we have the same components, except that we don't use the buzzer as well as the selector switches. Okay, so the power supply circuit has been modified such that we have here used the footprint for the Siemens logo power supply, and this is the model or the part number. And as you can see here, it is adjustable so that we can adjust the output voltage in case it's not exactly 24 volts, so we can adjust it between the values specified here. Okay, so now this is the electrical wiring, and this is the service outlet. You can see here, once we close the circuit, now the service outlet is energized, and now we have 24 volts generated by this power supply and passing through the protection fuse as we have seen previously. So now speaking about the input connections, okay, here we have the inputs or the input side of the main PLC, okay, where we have 8 inputs, and we have the power terminals. Specifically, we have the L plus denoting the 24 volts DC, and denoting the common or maybe the negative voltage or the ground in our case. And here we have the protection for the ground. We need to connect it as recommended by the manufacturer. So here we have a set of inputs, and we will see how those inputs are connected to the operator interface, and those are the overloads normally opened contacts. Okay, and now those are the normally open contacts of the power contactors. Here I'm asking you to justify their use in this circuit. So I need you to think carefully about the reason why we have used them in first place. Okay, so even though we are not utilizing the available inputs at the expansion port, however, we need to power it such that we can access the output side of the expansion port, since we need extra outputs, as you will see in a minute. Okay, so tracing back those wires will take us back to the operator interface, and we can just have a look at the operator interface now. Notice that the wiring has been modified. Instead of the control wire we were using in the previous implementation in the RLC circuit, here we are using the 24 volts DC in order to energize the input devices, namely here a set of push buttons, S1 to S4. Here we have S2 being the normally closed. Now remember, as per our Simulink model, we have chosen to use the stop push button as a first input, even though the tag used there was S1. So there is a flip between the tags assigned for the start and stop push button, so please be aware of that. Okay, and the remainder of the tags are the same. So this tells us that the inputs are actually syncing the current. How can we tell this? Okay, this is very easy. Since this terminal of the push button is connected to the 24 volts, and the other terminal is connected directly to the ground. So in case we are pressing, let's say, S1 push button, so we are actually connecting the 24 volt DC directly to the input, and that's why we have a syncing current. Okay, and those are the indication lamps or signal lamps, H1 to H3, and this is the ground wire. This is the same cable W1, even though I have just changed the internal connections. So coming back to the input wiring, okay, you can just trace the numbers and you can figure out which device or which component is actually connected to which input port. Now, proceeding reading the schematics, now we reach at the output of the two units, the main CPU and expansion unit. Here we are using output relay, and I would like you to notice here the benefit of using the output relay. Here we are dealing with two different components which actually requires different electrical potential. So specifically here with K4 and K5 we need to utilize 220 volt AC, while when dealing with the signal lamps we need to deal with 24 volt DC. Okay, so if we are using the transistor output, we will be unable to do this functionality that easily. Maybe we will need to use interfacing relays. Maybe we will come to that whenever we are implementing the same circuit or maybe other circuits using other PLCs where we have transistor outputs instead of relay outputs. Okay. So as you can see here we have the line, the AC line voltage coming into this terminal of the output relay Q1, and the other part is connected to the coil K4 through the normally closed contact of K5. And this is again, I would like you to think carefully why we have used this configuration. Okay. And keep in mind that this setup will be used by the students, so they most likely will be generating a lot of errors while programming the circuit. So maybe just to ensure the safety of the operation and to make sure that both K4 and K5 will never be energized at the same time. So I came up with this connection. Okay, so I give you almost the solution. Okay. And here are the outputs responsible for the signal lamps. As you can see here, once we can trace this, and this is the wire, and it will take us to the H1 lamp. Okay. So this is very important to keep in mind. Okay. So what about the other output port associated with the expansion port? Here we are only utilizing one output. Okay, as you can see here, and it is responsible for controlling the signal lamp H3. Okay, so now let's move on and have a look at the power circuit. It is exactly the same as before, and this is the operator interface we have just discussed, and this is the final power cabinet I showed you in the previous video. Okay, so as you can see here we have the circuit breaker, and this is the fuse housing, and this is the service outlet, and this is the power supply, and this is the CPU, and this is the expansion port, and those are the contactors, power contactors, along with their associated overloads, and those are the used terminals. Now this is very important. This is very important to note that here we are separating the control part from the power part inside of the power cabinet. Okay, and this is maybe in compliance with the various standards available whenever the machine builders are going to maybe mark their machines using CE marking or the like. Okay, so hopefully now you understand the wiring, and in the next parts we will focus mainly on the programming phase of the PLC device. I wish you all the best. Thank you.